So topic 3, we're going to talk about the AC method for factoring quadratic trinomials where A is 1. Okay. I think this is fun. I'd say this is a little bit harder than factoring where A is not 1. Technically, we're doing the same thing. It's just when A is 1, we have like a shortcut. So do remind yourselves that when we're talking about quadratic trinomials, we're talking about trinomials of the form ax squared plus bx plus c. A is always the coefficient of the squared term. B is always the coefficient of x, or what we call the linear term. C is always the constant, okay? So when A is exactly 1, we look for factors of C, the constant, that have a sum of B, the coefficient of the linear term. So that's what we were doing in the previous worksheet. In this worksheet, the issue is A is no longer 1. So we have to deal with that coefficient on the squared term. And we do this using the AC method. Now, there are definitely other methods for factoring quadratic trinomials of this form. There's trial and error, there's these weird box methods. I find students are generally the most successful with this method, so this is the method I teach. You're certainly allowed to investigate other methods if you'd like. So here are the steps that we take. Instead of just looking at the constant C, we have to look at the coefficient A, that's the coefficient of the squared term, and the constant C, and we want to multiply those. So we need to find the product AC, hence the name, the AC method. Now, what we do is we find factors of AC that have a sum of B. So that part's going to feel familiar. We're still looking for factors of a specific number that have a specific sum, okay? And then the really, I guess, uniquely different part is this part that I'm about to explain. What we then do is we take that middle term, that BX term, and we rewrite it. We break it down into the sum of two terms using the coefficients or using the factors from the previous steps as the coefficients. Okay, so what we do is we break down that middle term into two terms, and the coefficients of those two terms are going to be the factors that we just found. And because we now have a polynomial with four terms, we can factor by grouping. So that's why we've kind of highlighted and reminded ourselves of factor by grouping. Once you're done and you have factored, you can certainly check using the FOIL method. And then this right here is not going to come up in this video. It'll come up in the next video. But if you do have a situation where you don't have any factors of AC that have that particular sum of B, then you would say that that trinomial is prime. Okay? So let's go ahead and look at these. I don't think these are necessarily hard, but they're definitely longer problems. So always look to see if you have a GCF. If you have a GCF that you can factor out, sometimes factoring out that GCF gives you a quadratic trinomial where A is 1, and you can use that shortcut for factoring like we did in the previous worksheet. But if there's no GCF, you just have to do some other form of factoring. So AC method is definitely going to be needed for all four of these examples. So looking at part A, there's no GCF. So we want to look at A and C. Well, A is 3, C is 2. So we're looking at a product of 6, okay? So we need to find factors that have a product of 6, okay, or factors of 6. That means both factors need to be either negative or both factors need to be positive. So that tells me that I could have 6 and 1, 3 and 2, -6, -1, or -3, -2. And if you think about it, you can eliminate half your list. So you can always eliminate half your list if you just think about what you're doing. So we need a sum of +5. There's no way to add two negative numbers and ever get a positive sum. So right off the bat, we can eliminate the negative factors. They're just not going to work here, okay? So then when we look at 6 and 1, we have a sum of 7. When we look at 3 and 5, that's the pair that's going to work because we have a sum of 5. I think I said if we look at 3 and 5, if we look at 3 and 2, when we add those, we get 5. Okay, so what we end up doing is we break down 5x. We want to write 5x as positive 3x plus 2x. You could also write this as 2x plus 3x. Doesn't matter the order, just make sure the sign in front of the factor or the sign in front of the term is correct. And then I just bring down the rest of the problem. So I have 3x squared plus 3x plus 2x plus 2. And then I want to factor by grouping. So hopefully factor by grouping is getting a little easier. Ideally, by the end of this worksheet, you'll be a pro at it. Okay? So looking at the left-hand side here, We have 3x squared plus 3x. Well, the GCF there is just 3x. So I want to write out my GCF. Let me do that in black. And then a set of parentheses. And then inside the parentheses, I'm going to put the result after I divide these two terms by the GCF of 3x. So 3x squared divided by 3x. Well, 3 divided by 3 is 1. X squared divided by x, that's a quotient rule. We keep the base and we subtract the exponents. 2 minus 1 is 1. So I just get 1x. Okay? And then the second term, 3x divided by itself, well, anytime you take a number and divide it by itself, you just get 1. So we're going to go plus 1 here. Now we're done with the left side. We want to look at just the right-hand side. So looking at 2x plus 2, the GCF here is just 2. So because it's a positive GCF, I do need to put plus 2. You always want to, on the second half of factor by grouping, either put plus or minus with whatever that second GCF is. So I'm going to go plus 2, and then I divide each half by 2. Well, 2x divided by 2, the 2's just divide out to be 1. 1 times x is x, and then 2 divided by 2 is just 1. So hopefully you can see here that each half of this polynomial now, it's broken down into just two terms. The first term is 2x times x plus 1. The second term is 2 times x plus 1. Each of those terms has an x plus 1 binomial GCF. So we now have a GCF of x plus 1. Let me scoot that down just a smidge. We have a GCF of x plus 1. So I'm going to write down my x plus 1 and then a little set of parentheses. And then I'm going to divide each half of this polynomial by x plus 1. Well, x plus 1 divided by itself is 1. 1 times 3x is 3x. And then x plus 1 divided by itself again is 1. 1 times 2 is 2. So this right here is our final answer. And I'll remind you how to check yourself just on this one. And then for the sake of time, I won't check the others. But what you would do to check your answer is you would just FOIL. So I want to take x plus 1 times 3x plus 2. Well, x times 3x is 3x squared. X times 2 is 2x. 1 times 3x is 3x. 1 times 2 is 2. And when we simplify, we get 3x squared plus 5x plus 2. And this right here is exactly what we started with. So this one does check out. Okay? Part B, we have 5x squared minus 14x plus 8. Again, there's no GCF, so we need to start the AC method. So a times c is 5 times 8, which is positive 40. So again, we're looking for factors of a positive number, so both factors are positive or both factors are negative, okay? And let's kind of think about what this means. If we have these factors that have the same sign, and they have to have a negative sum, we want them to add up to be negative 14, we can eliminate the positive factors. There's no way you can add two positive numbers and get a negative sum. So we really only have to focus on the negative factors. So negative factors would be negative 40 and 1. 40 is divisible by 2. So negative 20 and negative 2. 40 is not divisible by 3, so you can skip 3. Definitely divisible by 4. It is divisible by 5. Not divisible by 6, not divisible by 7, and then we get 8 again, so you can stop. So if you ever get stuck and you can't figure out your factors, go to a calculator and just take that product, take a times c, and divide it by 2, 3, 4, 5, 6, 7, 8. Anytime you get decimals, toss them out. They can't be included. Anytime you get integers, see if the signs work. And then once you start seeing repeated factors, you know you're done. So which of these pairs adds up to 14? Well, or negative 14. Negative 10 and negative 4 have a sum of negative 14. So I would write this as negative 10x minus 4x, and then we can just drop down the rest of the polynomial. Again, you could write this instead of negative 10x, then negative 4x. You could certainly do negative 4x and then negative 10x. It's fine. Your factoring will look different, but the final answer will be the same. Okay, so let's go ahead and factor by grouping. So looking at the left-hand side, 5x minus 10x, the GCF here is 5x. So we divide each of these terms by 5x. Well, 5x squared divided by 5x, let's see, 5 divided by 5 is 1. X squared divided by x is just x, so we're left with just 1x here. Negative 10x divided by 5x, well, negative 10 divided by 5 is negative 2. And then hopefully you can see that x divided by x is just 1. Okay? So we're done on the left. Let's look at the right. On the right-hand side, we have negative 4x plus 8. Well, because the lead term is negative, the GCF has to be negative. The lead term is always the term with the highest degree, so that's going to be the negative 4x here. So because that's negative, we want to make sure our GCF is negative. So looking at 4x and 8, they have a 4 in common, but we need to make sure we write it as minus 4. And then we divide. So let's see, negative 4x divided by negative 4. Well, negative 4 divided by negative 4 is just 1. 1 times x is x. And then 8 divided by negative 4 is negative 2. And again, hopefully you can see that the two terms of this polynomial have a common binomial factor of x minus 2. So my new GCF is x minus 2. When I divide both halves by x minus 2, well, x minus 2 divided by itself is 1. 1 times 5x is 5x. X minus 2 divided by itself again is 1. 1 times negative 4 is negative 4. And there's your final answer. So if you want to FOIL it out to check, pause the video, FOIL it, and check yourself. Okay? Let's look at part C. Yet again, we don't have common factors. So a times c is 3 times negative 4, which is negative 12. You do have to be careful here. Now that we have a negative product, we need factors that have different signs. So as you're going through your list of factors, one has to be negative, one has to be positive. So we could have 12 and negative 1, 6 and negative 2, 4 and negative 3, or we could have negative 12 and 1, negative 6 and 2, negative 4 and 3. But just like with the previous two examples, you can eliminate half your list if you think about this. We need a sum of negative 1. Well, if you're adding two numbers with different signs, in order to get a negative sum, the larger of the two numbers should be the negative one. So if we look here, let's go ahead and just add our numbers up real quick so you can kind of see what I mean. Here we get negative 11, negative 4, negative 1. Here we get 11, here we get 4, here we get 1. Well, when we add the numbers where the larger of the two numbers is the positive, we get positive sums. When we add the two numbers where the larger number was negative, we get our negative sums. So you can see right off the bat, all of these can be eliminated because we're always going to get a positive sum. So when you're looking for a negative sum with two different signs on your factors, the negative sum is going to tell us that the larger of the two factors needs to be the negative one. So you could technically eliminate half your list right off the bat. What we really need to know is that we need negative 4 and positive 3 as our two factors. So when I rewrite this, I'm going to write this as 3x squared minus 4x plus 3x minus 1. You could certainly write this as 3x squared plus 3x minus 4x minus 1. It does not matter the order. The factoring will look different, but the final answer, I promise you, will be the same. And I wrote it in this particular order for a very particular reason, so you can see something that may come up. So looking at the first two terms, we have 3x squared minus 4x. Well, what they have in common is just an x. So my GCF on the left is just x. I divide both of these terms by x. 3x squared divided by 1x, 3 divided by 1 is just 3. And then x squared divided by x is just x. And then negative 4x divided by x, hopefully you can see that x divided by itself just divides out to be 1. 1 times negative 4 is negative 4. That's a little messy. Let me fix that. All right. Looking at the second half, I think this is supposed to be a 4. So please make sure you have 3x minus 4. I had 3x minus 1. So for the second half, we have 3x minus 4. Well, if you look at 3x and 4, they have no common factors, but with factor by grouping, we've always factored something out, and that is the case. No matter what your two factors are, you need to factor something out. And if they have no GCF, factor out either a 1 or a negative 1, depending on your lead term. If your lead term is positive, factor out a positive 1. If your lead term is negative, factor out a negative 1. Here, my lead term is positive, so I want to factor out a positive 1. Well, 3x divided by 1 is 3x. Negative 4 divided by 1 is negative 4. And hopefully you can see that each term here has a 3x minus 4 as a common factor. So we write down our new GCF, which is 3x minus 4. We divide both sides by 3x minus 4. Well, 3x minus 4 is 1. 1 times x is x. 3x minus 4 is still 1. 1 times 1 is 1. So there we have it. That is our final answer. Let me plug up before the computer dies. Okay, so last up, again, you can FOIL part C to see if everything works out if you want. Pause the video. All right, for part D, we have 6x squared minus 17x plus 7 or plus 12. There's no common factor, so we need to do the AC method. So A times C is 6 times 12, which is 72. Now, a lot of students get kind of overwhelmed when they're trying to find the factor pairs of A times C. If you have a number, something like 72, it's not impossible to do, but you do have several factor pairs. And if you start to feel overwhelmed, just go to your calculator. So let's go to the calculator. Calculator, we'll clear that out like you can't see it. Okay, so you want to do AC, which is 72, and we know that AC divided by 1 is just going to be AC. So 72 divided by 1 is 72. So then just start going through your integers. Do 72 divided by 2. Well, because we got an integer value out, one of our factor pairs is going to be 2 times 36. Let's see if 72 is divisible by 3. It is. So 3 and 24 is going to be a factor pair. Is 72 divisible by 4? Yes. So 4 and 18 is a factor pair. Hopefully you know that 72 is not going to be divisible by 5, but in case you don't know, go to your calculator. You get a decimal, ignore it. It's not going to be a factor pair. So then we do 72 divided by, or 72 divided by 6. Hopefully you know this is a factor pair. So 72 divided by 6 is 12. So 6 and 12 would be a factor pair. 72 is not divisible by 7. Prove it to yourself. Decimal, toss it out. 72 divided by 8 is 9. That's going to be a factor pair. If you were to keep going, we would get 72 divided by 9, which we know is 8, and then you just start repeating your factors. So at this point, when you see that things are going to repeat, stop, you're done. You have found all of your factor pairs. So just start dividing by 1, 2, 3, 4, 5, 6, and so on. Every time you get a decimal pair, toss it out. Every time you get an integer pair, look to see if the signs work. Let's go back to the worksheet. Okay, so we had 72 and 1. We had 36 and 2. We had 24 and 3. We had 18 and 4. We had 12 and 6. And then we had 9 and 8. Okay, now one of these columns of factors we can immediately eliminate. We know that we have to have a sum of negative 17. There's no way to add these positive pairs and ever get a sum of negative 17, so you can eliminate all of those factors. You don't even have to check the sum. We only want to look at the negative factors. So negative negative 72 and negative 1 is negative 73. Let's see, we get negative 38, negative 27, negative 22, negative 18, and finally, ding, 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 negative 17. So the magic pair of factors here will be negative 9 and negative 8, okay? So we want to rewrite this negative 17 term, and we're going to break it down into two terms using these two factors as coefficients. So we get 6x squared minus 9x minus 8x plus 12. We factor the first two terms. Hopefully factor by grouping is getting easy at this point. So factoring the first two terms, let's see, they have a 3x in common. Whoops, let me go back to black ink here. So let's see, they have a 3x in common, so we divide. 6x squared divided by 3x is 2x. Negative 9x divided by 3x is negative 3. Looking at negative 8x plus 12, since the lead term is negative, my GCF is negative, and 8x and 12 have a 4 in common, so I'm going to subtract 4 and then write my parentheses. Divide both of these terms by the GCF. Let's see, negative 8x divided by negative 4 is 2x. 12 divided by negative 4 is negative 3. Ideally, you can see that we have a common factor of 2x minus 3. And when we divide by 2x minus 3, we get, well, 2x minus 3's cancel, leaving us with 3x. 2x minus 3's again cancel, they just become 1, leaving us with negative 4. And there is your final answer. Okay, so that is how we factor quadratic trinomials where a is not 1. Again, there are other methods. There's something called trial and error. I've seen students use like a weird box method. Those are all fine if you want to investigate them, but I do find that this method is the one where students are generally the most successful. So that's why I teach this one. In the last video, we will look at special cases.